Good morning, everyone. This is Umakanth. Today, in this video, I'm going to discuss about the rectifiers. Actually, rectifiers plays a key role in electron device and circuit subject. Actually, coming to the rectifiers, actually, main purpose of rectifier is to convert AC into DC. Actually, our main question is what is the need to convert AC voltage into pulsate DC voltage? Actually, in more applications, we are using only DC voltage sources. So, in this purpose, we need to definitely convert AC voltage into DC voltage. So, for that conversion of AC voltage into DC voltages, we are using rectifiers. Okay. So, coming to rectification, actually in this slide, we're going to see that rectification is nothing but the process of converting AC voltage into pulsating DC voltage. Actually, the main uh, device using the main component using in the here is nothing but PN junction diode. PN junction diode plays a key role here. Actually, the main working principle of all kinds of experiments by using diodes. Actually, coming to the operation of diode works in only forward bias and it doesn't conduct in reverse bias. So this is the major operation for working of diode. So by using this operation of a diode, we are using this diode in rectifiers. So thus, the main operation of the diode is used in the rectifiers for converting the AC into pulsating DC voltage. Actually, here rectifier nothing but it doesn't convert AC into pure DC. There is a difference between pure DC and pulsate DC voltage. Actually, here rectifier will convert AC into pulsate DC voltage only. After by using for some filtering some other device, we need to convert the pulsate DC into pure DC. So actually we need to use a pure DC voltage. But rectifier will convert only AC into pulsate DC voltage. In the future slides, in the next slide, we are going to see what is the difference between nothing but pure DC and pulsate DC voltage. So first they coming to the definition. The rectifier is a process of converting the voltage into AC voltage into pulsate DC voltage. That we need to remember. Next, coming to the classification of rectifiers. Actually, rectifiers are classified into majorly three types. They are actually first one is half wave, second one is full wave, and third one is bridge rectifier. Actually, by the name itself, we can easily able to understand that it can indicate that half wave nothing but it will convert half of the wave at a time so that we are giving name it as half wave rectifier. Coming to the next wave, in the full wave rectifier, it is a rectifier which will convert the AC into pulsate DC at a time by converting the full wave so that we are calling it as a full wave rectifier. Okay, so next one is nothing but bridge rectifier. In the bridge rectifier, we are using four diodes and the construction is in the form of a bridge so that we are calling it as a bridge rectifier. So that in the first half wave rectifier, it will convert only half of the wave. Nothing but either it should be a positive or negative so that we are using only single diode for construction of half wave rectifier. Like coming to the full wave rectifier, we are using two diodes. It will convert the full wave, nothing but positive half wave and the remaining negative half wave. So that we are using two diodes for conversion of full wave rectifier. Coming to the bridge rectifier, we are using four diodes. Okay. So coming to the construction of a half wave rectifier, actually here the construction of the half wave rectifier. Actually, first we are using the transformer. Actually, we are using step down transformer. Actually, the purpose of step down transformer is convert from high voltage to some low voltage. What is the purpose to need to convert the high voltage to low voltage? Nothing but high voltage is doesn't able to withstand with the diodes. Actually, diodes are the low voltage devices, so that we need to use some transformer to convert the high voltage into low voltages. So we are using step down transformer. How can we find the step down transformer? Nothing but actually coming to the primary winding and secondary winding. In the primary winding, there are more number of windings when compared to the secondary winding. So that we are calling it as a step down transformer. Actually, if there is a step up transformer, nothing but there is a less number of windings in the primary, and coming to the secondary, there is high number of windings than the primary. So that then we will call it as a step up transformer. But here we see, but when we compare here in primary, there is a more number of windings coming to the less number of windings in the secondary, so that we are calling it as a step down transformer. So that whatever the input voltage we are giving for the primary voltage, it can withstand. Nothing but it can nothing matter make it down the voltages. Okay. Next one, the secondary voltage is given to the diode, nothing but this A and B is there, no? A and B voltages for the given. For example, for the primary winding, if I am giving the 230 volts as the power input voltage, the 230 volts is converted into, coming to the secondary voltage, converts to either 12 volts or 10 volts. Okay, the 10 volts or 12 volts is giving to the diode. Actually, for A and B, is 2 points is there. For the A point, I am giving the positive 10 volts, and same that negative 10 volts is given to the negative B. Okay, now the diode, actually the operation of the diode is it will conduct in forward bias and it will act as a off switch in reverse bias. Like this, it conducts and it will convert the input wave into output wave. Next one, this is the working operation. Actually, if we see here, this is the input voltage. We are the slide. We are giving the input voltage. The input voltage consists of positive half wave and the negative half wave. Coming to the output voltage. Actually, for the positive half wave, the diode acts as an on switch so that it will conduct and it will allow the input voltage to the output voltage. For the positive half voltage, for the negative half voltage, the diode acts as a off switch, so it doesn't allow any voltage to pass to the diode. So no voltage will pass to the output from the input, so that no voltage is present at the output. So coming to the next one, next wave again, positive half wave is presented in the operation. So if you give the complete cycle as the input voltage, but we will get the only half of the voltage as the nothing but positive half voltage as the output voltage. So that half wave, the name nothing but the name indicates that half wave in the sense that only half, total full wave, it will convert to only half of the wave, so that we are calling it as a half wave rectifier. Okay, next one, this is the same construction of same, nothing but for positive half cycle, and this is the for negative half cycle. For positive half cycle, it acts as on switch. For negative half cycle, it acts as a off switch. Next one, this is the coming to the limitations of half a rectifier. Actually, it allows to only half of the sine wave and other half of the sine wave is wasted. This is the leads to power loss. This is the major disadvantage of half wave, and it produces a very low output voltage. It is the second drawback of the half wave rectifier. This is the main drawbacks of the half wave rectifier. Next, coming to the next one is full wave rectifier. The what are the so many? We have seen so many disadvantages in of a rectifier. As to avoid the number of disadvantages in the half rectifier, we are going to use the full wave rectifier. In the full wave rectifier, actually, for the positive half cycle, we are using one diode, and for the negative half cycle, we are using the diode D2. So we are using two diodes D1 and D2 here for converting the AC into pulsated DC, so that it will convert total full wave, positive half cycle and negative half cycle into the pulsate DC voltage. So this is the operation of the full wave rectifier. Actually, in the full wave rectifier, we are giving AC input voltage. This AC input voltage is given to pulsate nothing but primary winding. The primary voltage 230 volts, for example, just we are assuming the 230 volts as the input given for the AC input voltage. It will convert the less than volt. For example, either 12 volts or 10 volts depends upon our application. Okay. Actually, here we are using the center tap transformer. Center tap transformer is nothing but actually there is a line, there is a voltage we are taking between the positive and the negative peak windings. Okay. So this is the center tap transformer we are using. Next, next after the we are giving the output to the diode D1. The positive diode conducts D1 and the negative cycle will conduct the D2 voltage. Okay, like this, we convert the complete cycle into pulsate DC voltage at a time. Next, this is the working of center tap full wave rectifier. Coming to the working of center tap full wave rectifier, actually, we have just seen here the operation of only positive diode D1 only. Okay, actually, if you see in here, actually, we are giving the sine wave as the input. The diode D1 conducts for only the positive peak, so that only positive peaks presented at the output side. Next, coming to the diode D2. Coming to the operation of diode D2, it will conduct to only negative half cycles, and negative half cycles will conduct as the from input to the output so that the input is transferred to the output. That is the purpose of diode D2. So coming to the output, final outputs here, the total input, nothing but sine wave, nothing but either positive peak and negative peak, totally presented at the output. So that coming to the 60, the output, first D1 will present and D2 present. Next, after then, again D1 present, again D2 is present. Now, this is about a full wave rectifier. Next, coming to the advantages, actually, the rectification efficiency of full wave rectifier is double than the half rectifier. Why? Because in half rectifier, we are using only single diode. In full wave rectifier, we are using only double diode, nothing but two diodes. So the efficiency of rectifier is double than the half a rectifier. That is nothing but half a rectifier uses only 40.6% of efficiency, and the full rectifier efficiency is 81.2%. So that is the major advantage of full rectifier. Next, coming to the next advantage of full rectifier is the output voltage and output power obtained in full rectifier is higher than that of the power obtained in the half rectifier. Actually, with the help of efficiency, we can easily find that the efficiency of full rectifier is more than the and more output power is also available in the full rectifier when compared with the half rectifier. Next coming to the what are the disadvantages? Actually, the main disadvantage using full wave rectifier is that in full wave rectifier, the main problem is we are using center tap transformer. Okay, actually, it is very difficult to connect the center tap transformer. That is the major disadvantage. Next, coming to the actually, we are using two diodes. That is nothing but which may, and also we are using the center tap transformer, which may cause a very expensive of the device. Okay, so these are all the some of the disadvantage of a full wave rectifier. Coming to the next disadvantage, the full wave rectifier is not suited to use when small voltage is required to be rectified. This is because full wave rectifier circuit, two diodes are connected in series and offer double voltage drop due to internal resistance. This is the major drawback of the another drawback of the full wave rectifier. Next one is the bridge rectifier. This is the third classification of the rectifier. Actually, already in the name said, in the construction of name said, bridge rectifier. Bridge nothing but the diodes are connected in the form of a transformer, nothing but in the form of a bridge. So that we are calling this type of construction is nothing but a bridge rectifier. So coming to the here, if you see the circuit diagram of bridge rectifier, actually we are giving the AC input voltage for the step one nothing but for the primary winding. The same voltage is given to the next one, nothing but secondary winding. So the output voltage is given to the nothing but the bridge format diodes, PN junction diodes. Actually, there is a point is there, A, B, and C, D is there. For C, D, and C and D, we are giving the voltages. A is grounded and B is taken as the load resistance as the output. So this is the construction point of a full bridge rectifier. Next, coming to the bridge rectifier operation. Actually, in the operation of the bridge rectifier, for the positive half cycle, D1 and D3 will conduct and it allows the output input voltage from input side to the output voltage. Next, the D2, D4 conducts for remaining negative half cycle and it will allows the voltage from input side to the output side. So it will allows the total voltage from input side to the output voltage. It also similarly works as a normal rectifier. Next, coming to the advantages, there are many advantages for full wave rectifier when compared to the normal full wave rectifier. Here, actually, there is no need of center traffic transform. This is the first advantage. Next, coming to the second one, the DC output voltage is twice than the center full wave rectifier. This is the second advantage. Next, third one is the PAV of the diode is half value of the center full wave rectifier. This is the third advantage. The design of the circuit is very easy when compared to the full wave rectifier and the half wave rectifier. That is the final advantage of the rectifier, nothing but bridge rectifier. Next, comparison of three rectifier. Actually, coming to the construction of half wave rectifier, full wave rectifier, and bridge rectifier. Actually, in the diodes, coming to the first parameter is number of diodes we are using. In half wave rectifier, you are using only one diode. Coming to the full wave rectifier, you are using two diodes. In full wave rectifier, you are using four diodes. This way, you can easily understand the difference between the half wave, full wave, and the bridge full wave rectifier. Next, second one is transformer tapping. Nothing but standard time transformer. Nothing but in half rectifier, we are using normal transformer. In center tap transformer, we are using center full wave rectifier, we are using the center transformer. Next, third one in rectifier, we are not using the center transformer. Next, coming to the peak inverse voltage. Actually, peak inverse voltage is normal V in half rectifier. Coming to the full rectifier, it is 2 into VM. Next, coming to the full bridge rectifier, it is also similar to the normal half rectifier. Next, coming to the efficiency of the different rectifiers, the half rectifier efficiency is 40.6% because only you are using the single diode and if you convert only half of the wave, remaining half of the wave is wasted. So this is the major efficiency problem. So next coming to the full wave rectifier, we are using 81.2%. Next third one, we are using the 81.2% as the efficiency of bridge rectifier. Next coming to the ripple factor, 1.21 is the ripple efficiency of the half wave rectifier. Next 0.48 is the full wave rectifier. Next coming to the another bridge rectifier also, the ripple factor is 0.48. Coming to the output frequency, the output frequency of F, now output frequency of half rectifier is F in, and half nothing but the output frequency of center full rectifier is also 2F into F in. Coming to the bridge rectifier is same. Coming to the DC current is the half rectifier DC current is IM by pi. Coming to the full wave rectifier and bridge full wave rectifier is nothing but 2 IM by pi. Coming to the DC voltage, the DC voltage is same. Nothing but when compared to the full wave rectifier and bridge rectifier, the half rectifier is the DC voltage of half rectifier is less than. Next, coming to the RMS current, the IM by 2 is the RMS current of half rectifier when compared to the center and the bridge rectifier.